Welcome back for another flight computer video. Today we're taking a look at the Aristo Aviat 610 and 615, which came on the market in the mid-1950s and were the evolution of the DR2 Dreieckrechner flight computer, which we looked at in a previous video. So you can tell that we have two sizes. We have the pocket size 610, which on the back is branded by Dennert Pape, and was made in Hamburg. The construction on this is a little different than the 615, so it's a couple of pieces of plastic with no sort of outer bezel to it. Just simple construction here. They're just all sandwiched together. We have a double-ended cursor on this side, and we have a single cursor on this side. You can tell that there's a lot of use of color, so we have red ink, black, and blue, and it's a lot of functionality in a very small package. And we compare that to the larger 615 flight computer. So this one was not marked as Dennert Pape. Aristo was branding of Dennert Pape, and later just became known as Aristo for these flight computers. And so this is the same, almost the same. We'll take a look at the differences here in a little bit. But what's nice about the construction of this is that the actual slides themselves are tucked into this this plastic casing, so that when you hold it on the sides, you don't restrict the movement of the slide itself. The serial numbers, you can find serial numbers on these computers right below the Aviat, and so the serial number on this one is 631. I don't know how to date this particular device. If anyone does, please leave a comment below. And you can see the original packaging that it came in, which was used not only for the 610 and the 615, but also for the E6B style Aviats, which were the 616, 617, 618, and a few others as well. So some quite nice packaging for these flight computers. They also came in leather pouches, so they could be carried as such without the box. A nice zipper on this one, and then just the smaller one just slid into place. So what I'd like to do is take a look at the wind side of the device in this video, and then we'll take a look at the calculation side in another video, since there's quite a bit of new functionality there. Okay, so here's the problem we'll work through. And what we'll see is that what's nice about the 610 and the 615 is that it combined the two sides of the DR2. So on the DR2, we had to calculate our relative wind angle on one side of the device and then transfer that relative wind angle to the other side of the device in order to find our wind correction angle and our ground speed. And what we'll see in this video is that we no longer need to do that. We can do everything on the same side of the computer. So quickly, in terms of scales, we have some helpers for cruising altitudes from the middle going out. We'll talk about those in just a second. Then we have 360-degree compass roses, both in black and in blue. On the outside of that, we have a sine scale, which goes from 0 degrees all the way around to 90 degrees, and then backwards from 90 degrees to 180. You can see 179 right here. So that is the scales. Oh, and sorry, on the outside, we also have 2-decade speed scale, logarithmic speed scale, which goes from speeds of 5 up to 50, up to 500, and actually some extensions go up to 1,000. So we also have this red arc, which was very similar to the red arc that we saw on the DR2, which shows where the common speeds are. And in terms of speeds from 150 to 500, these are speeds in kilometers per hour. So the problem that we're doing today will be in kilometers per hour. So let's just jump in and see how this works in practice. First thing, we have a given airspeed of 300 kilometers an hour, a wind from 090 at 65 kilometers per hour, and our true course is 310. So what we do is we set our airplane against 310, which is very clear. The airplane is going this way. Then we find our wind, which is from 090 on the blue scale, which is right here. And then we read our relative wind angle just inside that, which is 140. So we'll write our answer right here. Now, We don't have to turn the device around anymore. The problem is still the same though. We set our relative wind angle against our true airspeed. So our true airspeed here is at 300 kilometers per hour. And on the blue scale below that, we are going to set our relative wind angle of 140 degrees, which is set up just like that. Now, with that ratio set, we use the law of sines in order to find our wind correction angle, which is across from our wind velocity. So we look across from 65 kilometers per hour, which is right here, and we can read our wind correction angle of 8 degrees. And then finally, to find our ground speed, what we do is we subtract the wind correction angle from our relative wind angle, giving us 132 degrees. And across from 132 degrees on the sine scale, we can read our ground speed, which looks to me like it's about 347 kilometers per hour. So that's how the wind problem works. It works the exact same way on the smaller 610. It's just the numbers are a little bit smaller, but the functionality is identical. Now, the last thing that I wanted to talk about were the differences between these two devices, because there really aren't many. But if you look closely at this inner cruising altitude scale, you can see that we've got 3 numbers in each circle on the 615. And here we've only got 2 numbers. So what we're missing is the flight level reminders that we have on this outer scale. That's not present here on the 610. But there's a bigger difference, and it's a surprising difference. So if we look at what this helper table is doing for us, it reminds us of our IFR cruising altitudes and our VFR cruising altitudes when we're going in northeastern directions. And on the other side, we've got our IFR and VFR cruising altitudes when we're going in southwesterly directions. And these are very common. These are ICAO standards. So we fly at odd 1,000 feet or meters, which is also there, when we're going northeasterly directions, and even 1,000 feet when we are going in southwesterly directions. And if we're VFR, we add 500 feet to that. So you can see that listed there. Now, this looks like it's the exact same scale on the 615, but there's a subtle difference here. So we can, if we follow along on the right side, these things look familiar. We've got 3,000 feet, 5,000, 5,000 as we work our way down, 17,500 feet, 17,500 feet. So they appear to be the same. But when we look at the other side, well, first of all, there's no mention of VFR or IFR on the 610. And then when we start to look at what these numbers tell us, here we are going in a, what's the difference here? We're in a northwesterly northwesterly direction, a cruising altitude. It gives us an even 1,000 plus 500 feet. And you think, well, yeah, maybe for VFR, but what is going on here? And then you see the big difference, which is that we don't have 2 black rings on the inner side of the circle. We actually have 4 little segments. And this is actually a completely different system for choosing cruising altitudes. So this is the very common and now standard semicircular system, where we choose our cruising altitudes depending on whether we're IFR, VFR, and whether we're going north and east or south and west. Whereas here, this is the older, now I think defunct, quadrantal system, where we actually have 4 quadrants, and depending on our cruising altitude and our direction, depending on our direction, we choose different cruising altitudes in each of these 4 different quadrants. So here we have cruising altitudes from 0 degrees just shy of east, and then from east to just shy of south, and from south to just shy of west. So this is an older style, again, popular in the UK and some other European countries, which wouldn't help you very much today, but for historical purposes is sort of a neat thing to see. And it's a subtle difference when you quickly glance at the back of these 2 computers. They largely look the same, but there's quite different information in that table. So that's all for this first video. We'll do a second video to discuss some of the interesting conversions and scales that were found on the other side of the device. Thanks for watching.